All right, welcome. Today we're going to talk about inequalities. Okay, so we're going to go through kind of a couple sections of a particular textbook and kind of put it all together. But really, inequalities are very much like equations. So what we do with them is pretty much the same. There are some little nuances that we'll talk about in a second. So let's first talk about what an inequality is. There's four of them. We have less than, we have greater than, we have less than or equal to, and greater than or equal to. Typically when we graph these things on a number line, when we have something greater than, the arrow is going to typically go to the right. When we have less than, it's typically going to go to the left. If it's greater than or equal to, we're going to fill in the blank, the bubble, the point. And if it's not, we're going to keep it open. And when I was a student, I remembered that if we have extra ink here, we need extra ink here when we graph it. So that was a little memory trick that I remember my teachers teaching me when I was a student. Okay, so one thing to keep in mind is it helps visualize easier if we put the variable on the left side of this expression. So x is greater than 3. So when we do this, then the graphing makes more sense. So any value of x needs to be greater than 3. And you can pick any number, like say 5. Is 5 greater than 3? Yes, it is. So 5 would be an answer. So when we graphed, 3 would be here, and then everything to the right of it would be shaded on the number line. Now, if we look at this, 3 needs to be less than x. Okay, so visually, most people would put open circle and go left. But if that were true, that means if we go left of 3, 0 would be a solution. And is 3 less than 0? It is not. Okay, so what we do when we switch these is keep in mind if the variable is not on the left side, we're going to have to switch it to make things easier to see visually. The inequality symbol, look at what it's open to. So in this case, I was also talking about the alligator mouth. This looks like an alligator mouth, and it's eating the x value. And the alligator likes to eat a lot. And so the number it's eating is always bigger than the other number. So this number needs to be bigger than this number. So when we switch them, the alligator mouth, these two are the same expression by the way, the alligator mouth better be eating that same thing when we switch. Okay, so keep that little trick in mind. All right, now, what happens if we want to make things more complex? Because that's what math does. We take things and we can make them more complex to solve different problems. Okay, so for example on this, well, in an equation, we would add 3 to both sides. And in an inequality, we do the same thing. So in this case, we want x by itself, preferably on the left. And so we're going to do opposite of the number. Okay, so we get x is greater than 7. Okay, so now let's check our answer to make sure this is right. So pick an x greater than 7. Let's say 10. 10 minus 3 is 7, which is greater than 4. And that makes the solution true. Now when we graph this, 7 would be here, the circle would be open, and then we would shade to the right because the arrow is pointing to the right. Okay, if we look at this one here, we're going to now subtract 6 from both sides. So we get x is less than or equal to 6. Okay, well let's plug a number in. What value is less than or equal to 6? How about 0? 0 is always a good number to try if you can use it based on what's given to you. So 0 plus 6 is 6, which is less than 12. So 0 would be a solution. So when we graph this, here would be 6. We would circle it in and we would shade it to the right. And when we check, 0 is going to be on that shaded part, which means it's a solution to the inequality. All right, now, taking it a step further, we can also multiply or divide. Now this is where we have to be careful, because first let's start with a simple example. If this were an equation, we would divide everything by 2. Okay, so then we would get x is less than or equal to 2. So let's pick a number that's less than 2. How about 0? So 2 times 0 is 0, which is less than 4. So this would be true. And again, when we graph it, we want to plot 2 and then go to the left. And the circle is going to be closed in because there's extra ink here, there's extra ink in the circle. Okay? Now, if we have a division, we're going to undo that by multiplying. So we can divide both sides by 2, and we get x is equal to 8. Or sorry, x is greater than 8. Okay, so let's pick a number greater than 8. Let's say 10. So in the original equation, 10 divided by 2 is 5, which is greater than 4. So that would be true. And when we graph this equation, we're going to make a circle at 8. We're not going to fill it in because there's no extra ink, and then we're going to graph it to the right. Now, here's where things get confusing, and you have to pay attention to this. This is where students will get things wrong. In this case, we're going to divide by a -3. And when we divide by -3, the sign has to change, and I'm going to show you why in a second. So in this case, I'm not going to change the sign to start. So if I don't change the sign, my answer is x is less than or equal to -2. So a number less than or equal to -2 would be like -5, for example. So if I did -3 times -5, that would give me 15. Okay? And is that less than or equal to 6? It is not. Okay? So this is the reason why, to make this true, the steps are correct, but now we have to change the sign. So now the answer is x is greater than or equal to -2. What's a number greater than or equal to -2? I prefer 0. So 3 times 0 is 0, which is less than or equal to 6. Now this answer is true. And again, when we graph it, we plot the point at -2, and then we're going to go to the right. And it's going to be filled in, again, because there's extra ink under, there's got to be extra ink in. Okay? Now we get to multi-step, and this is where the equation components come in, where things can get kind of confusing. So we're going to move numbers to one side, like we did in this step. Okay, that's going to be probably the first step you do, is move numbers to one side of the inequality. We're going to multiply and divide to get the variable by itself on one inequality. Again, remember, if we multiply or divide by a negative number, the sign needs to change. Okay, and then there's special solutions. Because we may have variables on both sides, they may cancel out. And so what we have to do is, if everything cancels out, which we'll do an example of one in a minute, if the remaining solution is false, it's no solution. If the remaining solution is true, it's all real numbers. So every real number is a solution to that inequality. Okay, so let's take a look at this example here. So in this case here, we need to move numbers first, and we have a +5. So to move it, we're going to do a -5. So I have -v over 3 is greater than or equal to 1. Now in this case, this negative can go with the 3. And to get rid of that fraction term, we're going to multiply both sides by a -3. So on the left, we get -3, and on the right, we get v. But what did I forget to do in this case? I forgot to switch the sign. Okay? So now let's plug in. The v is on the right, so let's move it to the left so we can better understand this. So remember, the v is going to go on the left, and the alligator is eating the v. Okay, so now we need a v greater than -3. Well, a number greater than -3 is 0. So let's plug this in. 0 divided by 3 is 0. 5 minus 0 is 5. Is 6 greater than or equal to 5? That is true. So our solution in this case would be v is greater than or equal to -3. Okay, let's try one more. This is going to be a special case. Now in this situation, we can distribute too. We didn't talk about it, but we can distribute just like we do in equations. So we get 2k minus 10 is less than 2k plus 5. Now, in this case, because we're doing inequalities, and you see that each side has a 2k, if I move one of those across the equal sign, they both cancel out. So now I'm left with -10 is less than +5. Is -10 less than +5? It is true. So because it's true, all real solutions would make this particular answer set true. And we can make these, each side of the inequality can be made as confusing as we want, but we still follow the same steps as we would in multi-step equations. The difference is, if we multiply or divide by a negative, then we have to change the signs of the inequality.